12 out of 38. Before you install the agent, your whole feed is hyping. Look at that number. Last week, its maker reported that it beat the human expert baseline on one of the hardest AI benchmarks ever designed. That claim is why everyone is talking about it. This number is what happened when I ran a pre-registered 5-round test of its other headline feature, the memory that is supposed to make it self-improving. It failed round after round, and on one round, it reported a check that its own session record shows never ran. Half of this project may be the most useful idea to reach agents this year. By the end, you will know exactly which half to take, and the 1-minute test that protects you from the other. The project is called Prime Agent, and it is closing in on 14,000 GitHub stars, almost all of them earned in the 6 days since Prime Intellect announced it. There are no model weights inside it. It is a harness, the loop that runs around a model. And 2 separate ideas ship in that loop. The first, your long input never gets pasted into the model at all. It sits inside a live Python session as a variable, and the model writes small pieces of code to inspect it. List the files, slice the log, read the one function that matters. The model starts blind and queries its way to understanding. So a huge code base never drowns the context window. The second idea is the self-improving part. After each job, a refined step writes lessons, skills, and memories the agent can carry into the next one. That second idea is the one nobody had independently tested. Here is why your feed cannot stop talking about it. On July 24th, the ARC Prize team ran Claude Opus 5 on Arc AGI 3, their benchmark of 25 unseen interactive games, and published a record score of 30.2%, nearly 4 times the previous best. 12 days later, Prime Intellect ran the same model, on the same games, inside this harness, and reported 95.5, a hair above the human expert baseline. Same weights. The only thing that changed was the loop. Now that harness number is self-reported. It is not on the official leaderboard, and people are still arguing about whether a self-rewriting harness breaks the benchmark's rules. But notice what nobody in that argument was testing, the memory half. So I did. So I pre-registered a 5-task test. 2 copies use the same Prime Agent version: model, prompt, files, tools, and budgets. The learner kept one continuous session and ran /refine after each graded task. The reset copy started fresh every round. Each task was a different repository with visible tests plus hidden tests neither agent could see. The important question was not whether a note could be written. It was whether the next unfamiliar repository would trigger the right behavior. Round 1 was a CSV importer. Both agents inspected the project, wrote code, and scored 8 out of 8. The learner stored its first lesson. Then came a completely different repository, invoice math. The reset agent opened the files, implemented exact decimal calculations, and scored another 8 out of 8. The learner answered in 5.3 seconds. It declared done and described the CSV importer from round 1. But the new project contained billing.py, still ending in not implemented error. It opened no files, changed no files, and scored 0 out of 8. This happened before it had saved the correct repo mismatch diagnosis. Round 2 created the lesson. It did not ignore that lesson yet. After that failure, I gave the learner only the failed test names and allowed one refinement. Its diagnosis was exactly right. The failures likely indicated a repository or assignment mismatch. That warning was now durable state, written by the agent for its future self. This is the point where storage becomes learning, or fails to. Round 3 moved to a time zone scheduler. Would the agent inspect the new repository, or trust the stale answer already in its conversation? The fresh agent worked the scheduler and passed 7 out of 7. The learner answered in 4 seconds. It said, I rechecked the repository's README, and then described the old CSV project again. So I inspected the session record. The new prompt and the final answer are adjacent events. Between them, no shell command, no file read, no tool event at all. Zero tool calls. The verification it reported never happened. And its own saved playbook already contained the warning: repo mismatch, stored accurately, retrieved never, behavior unchanged. If that receipt just saved you from a bad install, that is what every video here does. Subscribe. And members get these tests first. Round 4 made it a pattern. The learner changed nothing again. Its 4 passing checks came from untouched starter code. By then, it had stored 3 separate warnings about missing symbols and the wrong repository. Round 5 was a blind database migration task in a new domain. The fresh session inspected the project and finished 8 out of 8. The persistent session answered in 3.3 seconds, touched no files, and scored 0. Final result: fresh sessions, 38 out of 38. Persistent session, 12 out of 38. And every point after round 1 came from starter code it never changed. It also consumed 24% more input tokens. The result is not that Prime Agent cannot code. The fresh Prime Agent sessions were flawless. It is not proof that every kind of agent memory fails. This test used one continuous session across 5 repositories with a nearly identical prompt. What failed in that protocol was the bridge between storage and action. /refine wrote useful lessons. But the next turn still followed stale conversational context. A saved note is not learning unless something retrieves it, checks it against the current environment, and changes behavior. You can test this in your own agent stack in 1 minute. Give the agent a task it believes it already knows, but place it in a clean project. Then watch the process, not the confidence. Does it identify the working directory? Does it open the specification? Does it inspect files before saying done? An instant answer with 0 tool calls is the canary. For a safer learning loop, start each job with clean task context. Inject only reviewed lessons. Require an environment check before execution. And use an external test or grader for success. Treat every memory write like a code change. Inspect it, scope it, and make it earn promotion. So here is the split verdict I would actually operate on. The context as a variable pattern is worth stealing today. In the research behind it, a smaller model that never read the input, it only queried it through Python, beat a bigger model that read every word by more than 34 points on a 132,000 token benchmark at comparable cost. If your work spans whole repositories, long transcripts, or logs that outlive a single prompt, that pattern is the point. And you can start applying it with the tools you already run by keeping big inputs in files, the model queries, instead of pasting them into the chat. Anything sold as self-improving memory, though, treat as unproven until it passes the canary you just saw. In my 5 rounds, fresh context beat learned context 38 to 12. And if you do install Prime Agent this week, read its own warning first. It is not a security sandbox, and it executes model-written Python with your user permissions. Give it a container, not your laptop. You came in looking at one trending agent. You are leaving with a split verdict. An idea worth adopting the next time you touch long context. And a memory feature that showed the difference between storing a lesson and acting on one. If you want the complete learner versus reset protocol and the 1-minute canary checklist, comment canary and I will send it to you.